Hello all, welcome all in the second part of paper solution of JEE Mains 10th January 2019 shift 2. Actually, due to some basic schedule, I was not able to conduct this session previously. So it has been a long time that I am conducting this session right now. Okay, so in last session of this paper solution, we had discussed something about 11 or 12 sums. Okay, so let's continue with this session and we'll continue with the solution. Okay, so in this session, the very first question we have is that let A1, A2, A3 up to A10 be in GP with AI greater than 0 for I equals 1 to 10 and S be the set of pairs RK for which this determinant has answer equals to 0. Then you have to find out that number of elements in S are dash. Now just check how we'll start. We'll first of all take this condition that A1, A2, A3 up to A10 are in GP. So I can say that here A1, A2, A3 up to A10 are in GP. So I can consider A1 as A, A2 as AR, A3 as AR square, dash up to A10 as AR raised to 9. The reason I'm writing capital R because I have already small r in the picture. Okay. Now, I will apply the operation directly into the determinant because I don't want to waste such space. So what I will do, I will just apply C2 to C2 minus C1 and C3 to C3 minus C2, right? Now, if you multiply this, if you do this operation, you will get the subtraction of log and log, right? So let me give you an example. What should be the effect on first element on this? It will be log E A raised to A2 raised to R into A3 raised to K minus log E A1 raised to R and A2 raised to K. Right, everyone? And as we know that if I apply log minus log, then it will be log E A2 raised to R A3 raised to K by A1 raised to R A2 raised to K, right? With the use of log X with base A minus log Y with base E equals log of X by Y with base E. So by using this property, and if you just observe that this will be the term in the first element. So can I directly write down all the elements? So just a minute, just check properly. This first row will remain as it is. Log E A1 raised to R, A2 raised to K, then log A4 5, that is log E A4 raised to R, A5 raised to K, and log E A6 raised to, A7 raised to R, 8 raised to K. Now when you do C2 minus C1, you will get log E A2 raised to R, A3 raised to R upon log E A2 raised to R, A3 raised to K by A1 raised to R, A2 raised to K. Similarly here, it will be log E A5 raised to R, A6 raised to K whole divided by A4 raised to R, A5 raised to K. Okay, just a minute, guys. Okay, so I just make it proper. See, you just check, right? So it will be your second column. Now same way, what about third column? So as I applied C3 minus C2, so 3, 4 by 2, 3. So I can say log E A3 raised to R, A4 raised to K divided by A2 raised to R, A3 raised to K. Same way here, it will be 6, 7. So A6 raised to R, A7 raised to K upon A5 raised to R, A6 raised to K. Same way the last will be A9 raised to R, A10 raised to K divided by A8 raised to R and A9 raised to K. Okay. And this already we have given equals to 0. Now what I will do, I will replace all these terms with AR square, AR and AR up to 9, right? So the first row will become, just check, the first row will become log E, A1 as small a raised to R and A2 that is A raised to K, R raised to K. Same way here, log E. Now just be careful. It is A raised to R, capital R raised to R, A raised to K and capital R raised to 2K divided by A raised to R, A raised to K and capital R raised to K. See, I just try to put values that A2 has AR. So AR to the power K like this, okay? Same way here. The first element will be A3, that is A raised to R, capital R raised to 2R, then A raised to K and capital R raised to 3K, all divided by A raised to R, capital R raised to R, and A raised to K, capital R raised to 2K. Chalo, same way, log 4. So log E, 4 will be A raised to R, capital R raised to 3R, and A raised to R, capital R raised to 4K. Same way, log E, just check. In numerator, A5 that is A raised to R, capital R raised to 4R, A raised to K, capital R raised to 6K. All divided by, sorry, it's not 6K, it will be 5K. Because it has 6 term, right? So 5K. Divided by A raised to R, capital R raised to 3R, and A raised to K, capital R raised to 4K. And this third element, this element we are talking about. So log E, A raised to R, capital R raised to 5R, A raised to K, capital R raised to 6K, divided by A raised to R, capital R raised to 4R, and A raised to K, capital R raised to 5K. And the last row will become log E, A raised to R, R raised to 6K, A raised to K, R raised to 7K. Log E, A raised to R, capital R raised to 7R, A raised to K, capital R raised to 8K, divided by A raised to R, capital R raised to 6R, A raised to K, capital R raised to 7K. And the last and the final element will be A raised to R, capital R raised to 8R, A raised to K, capital R raised to 9K, all divided by A raised to R, capital R raised to 7R, and A raised to K, capital R raised to 8K, right? And this whole elements are equals to 0. This whole determinant is equals to 0. Now when you just check all of them, so as I want to keep this first row, first column as it is, if I'm keeping this first column as it is, just check what I will get. So in the first column, so it is log E, A raised to R plus K, capital R raised to K. Same way, in this first row, let me talk about first of all. So log E, now just check carefully. A raised to R, A raised to R, A raised to K, A raised to cancel, right? Same way, capital R, and if it is capital R raised to 2K and here it is capital R raised to K, so you will get R raised to K in the numerator. So the only answer will be R raised to small r plus K. And the same thing you will get in the rest of the second column as well as third column. Just check what should be the element over here. A raised to R, A raised to R, A raised to K, A raised to cancel. 2R minus R, that is R. 3K minus 2K, that is K. So here again, I'll get R raised to, sorry, capital R raised to small r plus K. Same way. Now in the second row, here it will be log A with A raised to 2R into R raised to 3R plus 4K. But that does not have any concern with us. Okay. So A raised to 2R into R raised to 3R plus 4K. Now just check. The second element of this will be again RR cancel, KK cancel. 4R minus 3R, that is R, and 5K minus 4K. So it will be k. Same way you will get the same thing over here. Now in the third row, the first element will be, as I said, we don't have any concern with that. But as I want to write down that, so here it will be k. So here it will be r plus k. So I just need to change that. Though we don't have any concern, I need to write down the correct one. So a raised to r plus k and r raised to 6k plus 7k. But rest will be same. Okay, equals 0. Now, as we know, one of the property that if log x with power base, power n, so I can take that power in the multiplication. So now just check. What I will do, I will keep this first column as it is. Now, and from the rest of the rows, columns, I can keep log r plus k common. It will be log r plus k common, log r plus k common, log r. Same way, r plus k common, log r plus k common, log r, and r plus k common, log r equals to 0. Now, according to the property of determinant, here C2 equals to C3 implies for all the values of r and k, determinant has answer 0 only. Now you just tell me, is there any value on which your determinant is depending with r and k? We don't have any value. We don't require any value of r and k for which your determinant gets answer 0. Because whatever expansion you gave, on the basis of that expansion only, we got that these two columns are equal. Now, no matter with values of r and k you can use. Let me say that r equals 1 and k equals 5. Or I can say r equals 6 and 5, k equals 7. Whatever values of r and k you will put, you will definitely get this determinant as equals to 0. That means value of determinant does not depending on r and k. Therefore, S has infinite many solutions, right? As we are not depending on, determinant is not depending on any particular pair of r and k. And hence that should be your, that will be your answer. That is option number 1, as you can check. Okay, see, it looks quite difficult and also quite complicated, but once you know this, you can get some direct idea from the questions only. Okay, so moving with the next. Sure, just check. Number 2 has on which of the following lines lies the point of intersection of line and plane? That means from 4 options, you need to find out a line for which this intersection of point and line, right, is lying. So firstly, I need to find out the intersection of this line and point. So what I will do, that let M be the point of intersection. Be the point of intersection of line and plane. That means M belongs to L and M must be belongs to plane also. So what I will do, I will make the coordinates of x, y, z from the line. So let's say x minus 4 by 2 equals from the given line, y minus 5 by 2 equals z minus 3 by 1 equals k. So I can say that x, y, and z equals to twice k plus 4, 2k plus 5, and k plus 3. This should be the coordinates of M, right? And as M is also lying in the plane, we can put x, y, and z in the equation of plane. Okay. So as I said, that we need to put this value of M, x, y, z in the equation of plane. So by putting those value into the equation of plane. So now what I will get, x as answer 2k plus 4 plus y as answer 2k plus 5 and z has answer k plus 3 equals to 2. Hence 5k plus 12 equals 2. Hence 5k equals minus 12. So k will get as minus 2. Therefore, the point of intersection will be let us put this value of k into this coordinate of m. So minus 4 plus 4, that is 0. Then minus 4 plus 5, that is 1. And minus 2 plus 3, that is 1. So this will be the coordinate point of intersection. And now what you need to do? You need to put this point into the 4 options to get the answer. Right? So just put 0, 1, 1 into the options and check that which will give you the same ratio. So as you put x equals 0 here. So 0 minus 2 by 2, that is minus 1. Then 1 minus 3 minus 2 by 2, that is again minus 2. And 1 plus 3, 4 by 3, not possible. So this is not our answer. Option A. Let's check for option B. 0 minus 4 by 1, so minus 4, okay. Then 1 minus 5 minus 4, chalo, correct. So this two both gives us same answer. Here 1 minus 5 minus 4, right? But it has minus in denominator, so minus minus plus, so this won't be our answer. Moving with the next one, 1 minus 1, 0. So here itself it is cancelled. So this is also not the answer. Okay, because what I need to check? I need to check that which will follow the condition. Okay, so now let's talk about this. So x plus 3, that is 0 plus 3 by 3, that is 1. 4 minus 1, right? 4 minus 1, that is 3 by 3, 1. And 1 plus 1, 2 by just a minute. So here there must be some mistake with the options, because if this is correct, then compulsory any one of the option must satisfy the answer. If you just check that option B and option D has almost these two ratios are equal, but there is a difference in the third one. So either you can have difference or a mistake of minus sign here or the minus sign here. Okay, so that will be the mistake that I need to check, but else the method will remain same, that I have to check the find out the point of intersection, and this is the common method to find out the point of intersection, that make xyz as a subject and put that point and in form of k in the equation of plane to get the value of k. And once we are able to get that, we'll get the point of intersection. Okay, sure. And let me write down that, then check from the option. Okay, sure. Sure. Then the number of values of theta between 0 to pi for which the system of linear equation has non-trivial solution. Now just check, this system is a homogeneous system. And homogeneous system with non-trivial solution, that means it has infinite solutions. Confirm. And if it has infinite solution, then the determinant made by the coefficients of x, y, and z must be 0. Right? So here sine 3 theta, cos 2 theta, and 2, that is equals to 0. So here I can just write down like this, that 137 minus 147 sine 3 theta, cos 2 theta, and 2, that is equals to 0. So let's try to expand this and find out the value. So 1 into 8 minus 7 cos 2 theta, minus 3 into minus 2 minus 7 sine 3 theta, and plus 7 equals to 0. Chalo, let's try to convert the whole equation. Wait a minute, let me give you first expansion. Right? So let's try to convert the whole equation in form of sine theta. So it will be 21 sine 3 theta, that is 3 sine theta minus 4 sine cube theta plus 6, 8, 14 plus 7, that is 21 minus 7 cos 2 theta, that will be 1 minus 2 sine square theta equals 0. See, I need to convert whole the equation in form of a single variable, right? So it's 63 sine theta minus 84 sine cube theta plus 21 minus 7 and plus 14 sine square theta equals 0. So I will get minus 84 sine cube theta, then plus 14 sine square theta plus 63 sine theta and plus 14 equals to 0, right? Now from rest we can take 7 common, right? Actually I made a mistake, sorry for this. I did some wrong expansion. I forget to multiply something. Wait a minute guys, sorry for this. So it's 7 into minus cos 2 theta and minus 4 sine 3 theta, that I need to write. Okay, now let's give the expansion. So 8 minus 7 cos 2 theta plus 6 plus 21 sine 3 theta minus 7 cos 2 theta and minus 28 sine 3 theta equals 0. Now just check. So 21 minus 28 minus 7 sine 2 theta, sorry 3 theta, then minus 14 cos 2 theta and plus 14 equals to 0. So 7 common. So sine 3 theta plus 2 cos 2 theta and minus 7 or minus 2 equals to 0. And now let's convert in form of sine 3 theta, that is 3 sine theta minus 4 sine cube theta plus 2 into cos 2 theta, that is 1 minus 2 sine square theta minus 2 equals 0. So 3 sine theta minus 4 sine cube theta plus 2 minus 4 sine square theta and minus 2 equals to 0. So 2 cancel. Hence it will be minus 4 sine cube theta minus 4 sine square theta and plus 3 sine theta equals to 0. Let me bring my minus sine theta common. So we'll get sine 4 sine square theta plus 4 sine theta and minus 3 equals to 0. So hence either sine theta equals to 0 or 4 sine square theta plus 4 sine theta minus 3 equals to 0. Okay, so the factors will be 4 sine square theta plus 6 sine theta minus 2 sine theta minus 3 equals to 0. From the both the sides, both the terms, we can get 2 sine theta common. So we'll have 2 sine theta plus 3 minus 1 common. So 2 sine theta plus 3 equals 0. Therefore, either we get sine theta as minus 3 by 2 or sine theta as 1 by 2. But as we know that this cannot be possible, right? So only sine theta will be half or sine theta will be 0. Now as the interval given to us is in between 0 to pi, which is an open interval. Okay, which is an open interval. So sine theta equals to 0 also does not belongs to 0 to pi. Okay, so here theta does not belongs to 0 to pi. So only this can possible. And as sine theta is half, so it can be either in the first quadrant or in the second quadrant with either pi by 6 or 5 pi by 6. Hence theta has only two values. First is pi by 6 and second is 5 pi by 6. Okay, so we'll get two values and just check. This is the same option we have, that is two values are possible. Okay, so it is again looks quite easy, right? Just a better concept you need to keep in your mind, that what if a homogeneous system with non-trivial solution has condition. Okay, so moving with the next one. Okay, so next question is from the conic section. See, we need to find out that S is represented by y square upon 1 plus r minus x square upon 1 minus r equals to 1. So if it is representing hyperbola with eccentricity for 0 less than r less than 1, if it is representing an ellipse with eccentricity 1 by root 1 plus r for r greater than 1. See, so here we need to check two cases compulsory. First case for r greater than 1 and second case for 0 less r less than 1. So let me check first 0 less. See, as we know that we know the answer, but when in the examination, when you don't know the answer, you will have to check both the cases, but right, as well as option is concerned. So first case, let me take 0 less r less 1. See, when it is 0 less r less 1, see, 1 r is always positive. Clear. But what about 1 minus r? So minus, when I multiply, inequality has been changed. So 0 less 1 minus r less 1. That means 1 minus r is also positive. Okay. So if 0 less r less 1, then this 1 plus r is also positive and 1 minus r is also positive. So this equation, therefore, the given equation represents hyperbola. Hope you all are clear with this. Right? If 0 less r less 1, we discussed that 1 plus r is positive and 1 minus r is also positive. So there will be minus sign remaining as it is. Okay. So what we can consider that for 0 less r less 1, equation will always represent as parabola. Sorry, hyperbola. So is there any condition that hyperbola with 0 less r less 1? Okay. So in both the cases it has. So let's find out the eccentricity. So here, therefore, what I can say that A equals root 1 minus r and B equals root 1 plus r. So the eccentricity as equation A square plus B square by B square, that is 1 minus r plus 1 plus r divided by 1 plus r. So A square will be 2 by 1 plus r and E will be root 2, right? Root 2 by 1 plus r. So this will be your answer. Now just check, is it satisfied with the option that when 0 less r less 1, the eccentricity will be root of 2 by 1 plus r, but it is not given. So not 1, neither 1 nor third is the correct answer. So let's talk about the second case. Number 2. When r is greater than 1, compulsory 1 plus r is greater than 0, but minus r less than minus 1, hence 1 minus r less than 0. So I need to get 1 r minus 1 to get positive answer. So what will be the case? So y square by r plus 1. And now to convert in terms of an equation with positive sign, I need to get this as positive. And for that, I need to take minus sign common. So now it will be plus x square by r plus 1 equals to 1. Another point is, why I need to make such values as positive? Sorry, just a minute. R minus 1. Because we all know that no matter with the parabola or hyperbola, the denominator must get the positive answer, must need the positive answer. And to get that positive answer, I need to get minus sign outside and put R minus 1. Okay, sure. Now just check. Now for any greater than 1 value, any value greater than 1, r plus 1 is always greater than r minus 1. Also, r plus 1 is greater than r minus 1. So here your A will be root of r plus 1 and B will be root of r minus 1. And now let me apply the equation of eccentricity. So eccentricity of an ellipse will be A square equals A square minus B square by A square. Chalo, let me check what is A square and B square for us. A square is r plus 1. So it will be r plus 1 minus r minus 1 upon r plus 1. So r plus 1 minus r minus 1 is plus. So it will be 2 by r plus 1 and therefore E has root of 2 by r plus 1. And this is for which value of r? This is for r greater than 1, representing an ellipse, right? And now when you just check the options, you will get your answer that this equation will represent an ellipse with eccentricity 2 by r plus 1. So D is your answer. Clear, everyone? So in this case also, you must need a proper understanding of a conic section, right? So let's move on with the next question. Now this question belongs to a definite integration. What is given to us? We have 0 to x ft dt equals x square plus x to 1 t square ft dt, and you want to find out f dash of 1. And this question must require the idea of a Leibniz equation. So let me show that Leibniz equation. So it has d by dx of ux to vx ft dt. I said Leibniz equation, right? I'm writing the Leibniz equation. So it has f of vx into v dash x minus f of ux into u dash of x, right? This is one of the most important and general equation for JEE related to the definite integration chapter. See, so Leibniz equation representing what? That when you have a term with variable t, and if you are doing the integration with respect to t, but that integral has limit with respect to x, and also if you're doing the derivative with respect to x, so integration is applying with respect to other variable, and differentiation is also applying with different variable. So in that case, you need to apply Leibniz rule. And that rule is you need to put this above limit into the function, into derivative of above limit, minus put lower limit as a function into the given function, into derivative of it. So if I apply that equation over here, so here above, I need to do the derivative on both the side. Okay, so applying derivative on both the side, let me write down that. I'll get d by dx of 0 to x ft dt equals d by dx of x square plus x to 1 t square f of t. Just for your concern, I'm just writing. And now let's do the derivative. So upper limit, if you want to put, then fx into x as derivative 1, okay, minus f of 0 into 0 has derivative 0 equals x square as derivative 2x plus, let us put the above limit. So 1 into f of 1 and derivative of 1, that is 0, minus x square into x square, right? Sorry, x square into fx, and x has derivative 1. So now it is fx equals 2x. Now this term will be 0 minus x square fx. So if I want to make fx a subject, I will get 1 plus x square equals 2x. Hence, I will get fx as 2x by 1 plus x square. Now, once you get this, let's go with the derivative. So f dash x will be the square of denominator as it is, numerator as derivative 2, minus numerator as it is, denominator as derivative 2x. So 2 plus 2x square minus 4x square whole divided by 1 plus x square whole square. And therefore your f dash x will be, it's 2 minus 2x square by 1 plus x square whole square. And now I want f dash of 1, right? I want f dash of half, sorry. So let me put x equals half. Therefore f dash of half will be 2 minus 2 into 1 by 4 upon 1 plus 1 by 4 whole square. So 2 minus 1 by 2 into 1 upon 5 by 4 whole square. So 2 minus 1 by 2, that is 3 by 2 whole divided by 25 by 16. And hence your final answer will be f dash of half 24 by 25. You can easily give the expansion here, right? So this will be your answer, that is 24 by 25. 2 is the answer. Okay, so it is very much required to keep this theory, Leibniz rule, in your mind. Otherwise, you won't able to solve this question. Moving with the next one. Okay, now in this question, just check. This is belongs to either you can consider from PNC also, or you can consider from binomial also. Okay. Now, see, whenever you have this kind of question, don't start putting value of R. Okay. First, try to give the expansion what is given to us. Let me check this. See here, I have 50 CR into 50 minus RC, 25 minus R. Let me give some expansion in this case. So it will be 50 factorial upon 50 minus R factorial into R factorial into 50 minus R factorial. Now just check carefully. 50 minus R minus 25 plus R. So it will be 25 factorial into 25 minus R factorial. Hope you are getting this. Right? What I did, I just gave the expansion here. Okay. So 50 CR, that is 50 factorial upon 50 minus R factorial into R factorial. Then 50 minus R factorial upon 50 minus R minus 25 plus R. So minus R plus R cancel. 50 minus 25, that will be 50 factorial, sorry, 25 factorial, and into 25 minus R factorial. Now, how many things we can cancel? So I can say it is 50 factorial as it is divided by 1 upon, or let me say it is 25 factorial into R factorial 1 upon 25, or let me write down 25 minus R factorial into R factorial. Just a minute. If I do 25 factorial multiply and 25 factorial in the division. Now, and let me bring this 50 factorial upon this 25 factorial, I can write down as 25, 50 minus 25 into 25 factorial into 25 factorial by 25 minus R into R factorial. So now you can easily say that this will be 25C25, 50C25, and this will be 25CR. Am I right or not? Just check. So whatever term we have, right? Whatever term we have, I convert that term in form of 50C25 into 25CR. And now just check. The term which you have on the right side already has 50C25. So now what is given to us? So now summation R equals 0 to 25. Just check. 0 to 25. And instead of this, I can replace that as 50C25 into 25CR, and that is equals to what? K into 50C25. So as 50C25 will be the constant term, so I can cancel out from both the side. And in this, if I apply R, so it will be 25C0 plus 25C1 plus 25C2 dot up to 25C25 equals K. So what should be the answer? This must be 2 raised to 25. A very simple one. So that is C is your answer. Okay. So hope you all clear with this. Right, everyone? So let's just end the session here, because as we already have only 4 or 5 questions left in this session, in this paper solution. So we'll discuss them in the next session. Okay, and hope you all clear with this. We have discussed so many important theoretical points in this session, right? And hope you all clear with this. So thank you from my side.